Good evening. It's 10:15 at night, and we're just getting started on day 12 of Advent of Code. So we'll see how this goes. I'm not going to stay up till 2 a.m. to finish this, so we're going to try to do as much as we can, and hopefully put a solution in tonight. I had to work from the office today, so I couldn't work on this over lunch, and then the Rams game was tonight, so I wanted to watch that. So I waited to do this until after I watched that game, which they did win. So it's a plus. They're still in the playoff hunt. Okay, let's get going here. Day 12's puzzle is called Garden Groups. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map, your puzzle input, of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching horizontally or vertically, they form a region. For example, A is a region. This 4x4 arrangement includes garden plots growing 5 different types of plants, labeled A, B, C, D, and E, each grouped into their own region. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and that region's perimeter. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, and C plants are each in a region of area 4. So A means area 4. Okay, that's pretty simple. The type E plants are in a region of area 3, and the type D plants are in a region of area 1. Each garden plot is a square, and so has 4 sides. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. The type A and C plants are each in a region with perimeter 10. The type A and C plants are in a region with perimeter 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay. All right. So even like the top edges and the right, and left edges count as part of the perimeter. Each garden plot is a square. Oh, no, I lost it. The type B and E plants are each in a region with perimeter 8, and the lone D plot forms its own region with perimeter 4. Visually indicating the size of plots in each region that contribute to the perimeter using dashes and pipes, the above map's region's perimeters are measured as follows. The plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. For example, the above map contains 5 regions, one containing all the 0 garden plots, and the other 4 each containing a single X plot. The 4 X regions each have area 1 and perimeter 4. The region containing 21 type O plants is more complicated. In addition to its outer edge contributing a perimeter of 20, its boundary with each X region contributes an additional 4 to its perimeter, for a total perimeter of 36. Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. In the first example, region A has a price of 4 times 10 equals 40. Region B has a price of that, region C, and so on. So the total price for the first example is 140. In the second example, the region with all the O plants has a price of 21 times 36, and each of the 4 smaller X region has a price of 1 times 4, for a total price of 72. Excuse me. Here's a larger example. It contains all of this. So it has a total of 1,930. What is the total price of all fencing? What is the total price of fencing all regions on your map? So, looking at this, the first thing I'm thinking is I'm thinking back to which day was it? I think it was day 6. Yeah, the guard Gallivant problem. So this was kind of a flood fill problem where we walked over the map, basically checking. There was also a problem that we just did. Was it the 10th? This one? Yeah, get trail paths, where we did a breadth first search. So I think we can use a similar solution here, where so we'll parse the input, or we'll parse the input to a garden, and then I'm thinking we should be able to keep track of where we've been, and then keep track of where we've been. Yeah. So here's what I'm thinking. What am I thinking? So we're gonna walk the garden. We're going to walk the garden, and then at each place, just like on the hoof it solution, at each place we're gonna look at the current character, and we're basically gonna explore the tiles around it. We can do a breadth first search with a Q, and we'll explore the tiles around it. And I think we only need to explore. Let's see. Do we need to go in diagonals? Do we need to explore the diagonal directions? I don't think so. We just explore up, down, left, right, and basically look for our region, and we'll build up our region, and then whenever we find a part of our region that's essentially an edge, we can identify perimeter. Is what I'm thinking. Does that make sense? I think it makes sense. Let's get started. Let's just dive in here and see if we can fumble our way to glory. Yeah. Let's start with let's start with a region. So we're going to have class region. And this is essentially going to be the object that we use to kind of keep track of area and perimeter when we're doing our breadth first search. So we will say class region, and it's going to need 3 things. Actually, it's only going to need 1 thing, right? It's just going to need a character, which is going to be our plant. Or type of plant. So we can call this plant type. Plant type. It's also going to have a private int of area, and this guy's just going to have a getter. Actually, it doesn't even need a getter. This actually could just have a private. This could actually be a field, and we could just say private int area, and that's always going to start at 0. And it's going to have a private int perimeter. Is also going to start at 0. And then the region is going to have a price. And that price is going to be or this region can calculate its price. Private int calculate. They call it price for a region, or is it the fence? Calculate. I'm just gonna call it calculate fence price, and that's gonna be super easy. That's just area times perimeter, like that. And then we're gonna have, we need some way. I'm going to have some public methods that do the manipulation of this. So, oh, this actually needs to be public too. This is public. I'm going to call this public void increase area. And that's going to be just area plus plus, and then public void increase perimeter. And this isn't strictly necessary. I just kind of like the idea of having some methods that encapsulate that operation instead of me having to do that on some sort of public property. Okay, real quick, let's add a couple tests for this. You may say this is unnecessary, but I say It is, and I probably should have written these first. Just something sometimes I'm bad about doing. Sometimes writing tests first is good because you can write your tests. You can kind of use your tests as like a sample program, right? So you kind of explore what you want the shape of your class or your class's API to look like. And that, yeah, so that, I don't know, writing tests first is definitely helpful. And I should do that more. So async task, and we'll call this, oh, does this need to be a public thing? Yeah. So make this a public var type just a getter set to type. There we go. Oh, you're right. That is redundant. So oh, what was it? Okay, region. So we'll say region and instance constructed should set plant type property or region new region, and let's just do a say wait assert dot that region dot plant type is to plant. Where's my test there? Here we go. We'll do another one for task public async task increase perimeter and all it should region perimeter. Var region, new region. Although I don't know if I'm 100%. I don't know. I don't know if I 100% love. I don't know that I 100% love the mutation of the class's state. It's not something I usually do. It is what it is. Okay, so we'll say var region, give it a character, then we'll say region dot increase perimeter and await assert var area equals region dot calculate fence price. Yeah, maybe I do want these to be prop properties. I can say var weight cert dot that region dot perimeter is equal to 0. Let's go back over here and let's actually turn these into properties, but we will call them public ints area, and this will equal a getter, and we'll make the setter private. That. No, because I'm actually gonna test that it's it that do the same thing with the area. Increase perimeter, increase area, and called it should increase area. Area. Those should all pass now. Oh, shouldn't be 1. Shouldn't be 0. Should be 1. We'll do calculate size. Test public async task. Calculate price. Yeah, calculate price. Called code return expected. So we could say var region, new region, var result equals await, no, not await, region dot calculate fence price, await assert dot result dot is equal to 0. Because we didn't call anything, so it should just be 0 times 0. Easy peasy. All right, now that we have our region, we need our garden. And our garden, what's our garden gonna have? Our garden is gonna have, well, let's look back at our hoofit solution. All right, and let's look at our map. So, steal our method here. property. Let's put that here. Let's call it walk garden. And so we know we're going to have a private read-only string array. That's going to be our grid. And we're going to have a private constructor that's called garden that takes the grid and then sets that grid property. Then we're going to have a public static method that returns a garden called from input. It just hands us back a new garden. And then our garden method garden method is going to have what? It's basically going to have a method that calculates the total fence price for the garden. It's going to look kind of like this, right? So in here, when we're walking, we're calling this method to get the trail pass. And I think what we need to do is we need to say so in our garden class, we need something called public, just to return, excuse me, I'm gonna say calculate fence price. Then we're gonna have our total 0. Then we're gonna walk garden, and we're gonna give it a lambda, and that lambda is always gonna have the current x and y. And we can actually reuse that same reuse a lot of that same code. So we have position, and I have direction in here too. Where's direction? Not pull that into. Oh, there it is. Yeah, so we can do this again. Get out of here, get out of here. Get out of here. What's it complaining about? Yeah. I don't think I need height. If anything, that would just be a character this time. Be a char. plant type, that's fine. Plant type. Default to period. Position, next position, plant type. Only we're not parsing this. We don't need to parse this. We can literally just say, we don't even need this check here. Yeah, position, plant type. Oh. Then we need to walk the garden. Our topo map from our earlier solution. This we don't need to care about. We literally just need to say this, and then this. Okay, so we need another method down here somewhere that's called public region find region, and that's going to take in a position. And for now, we don't know what we're going to do there yet. This is where we're going to implement our breadth first search, actually. So do and then this will literally be var region equals find region, and we'll pass in x and y. Oh no, we'll pass in new position x, y, and grid y, x. And that looks weird. I've said this in a lot of videos. This looks weird saying grid y, x, but remember, because we're just taking the lines of our input, the y refers to the row, right, which line we're on, and then the x refers to which character we're at. So that's why when we actually get the actual character from our grid, we flip these and we go y then x to find the actual position. So and then once we have the region, we just say total plus equals region dot calculate fence price, and then the region that we hand back will have the right perimeter, will have the right area, because we're going to do all that here in the find region method. Oh, and this can actually be a private method. So let's copy that same implementation from here. It could be very similar. We're just going to be changing the criteria. I probably should build some like if I keep doing admin of code every year, I should probably build some like helper libraries, right? That would be good. Okay, so what do we want? The first thing I think we'll do, so a region can just be one. Keep in mind, right? So a region can just be one X like they showed. So the first thing we need to do is we need to create a region. So instead of a trailhead score, the thing we're going to get back is a region. So we'll say var region equals new region. That's going to take a single character. And actually, I don't know why. Let's give region a similar treatment as we did the garden, right? Let's say private region character plant type type like that. Let's get rid of the primary constructor. Static. It's called that returns a region. It's called from. And it's kind of nice. We can actually do a character. So we can call it plant type. Say new region plant type like that. But we could also overload this, which was one of my favorite features of C#. And we could also say public static region from position, and this would be equal to new position dot plant type like that. Then up here, we'll have to change our test a little bit. We'll have to say region dot from a. Yeah, I kind of like that from a object creation API. I kind of like that static from method. Sometimes the new keyword looks ugly. But in a year, I'll decide otherwise. I always vacillate back and forth on like API style and I'll look at this code today and be like, oh, that's really nice, and then I'll look at it in a year and be like, oh, why did I do that? That's so stupid. Okay, so we'll say region, and we can say region dot from position. Which also means here, we actually shouldn't be setting this equal to. If we've reached this point, then we know our region has at least an area of 1. Does that make sense? So we can initialize area to 1. The perimeter though, we can't do that because the perimeter we can't do that. So this actually needs to change to 2. This is going to change to 1. Right, so Like this has an area of 1, it has a perimeter of 4 because there's nothing around it. But if you had something like, where's a good example? There's really not a good example, is there? Nonetheless, yeah, nonetheless, it needs to be. Oh, this doesn't need to change. This is still going to be 0 because it's still going to be 1 times 0. So maybe it doesn't even matter that I set this to 1. Does it matter? I feel like it does matter. I guess what I could do is not do that. We can actually just take that care of that when we're looping. So we do want to keep track of the visited positions, and we do want positions to visit. The first thing we'll on queue is our position. That's the first thing we come in with. We'll dequeue it. And we want to first see we don't care about this anymore. And I don't think this matters. So if the position has been visited, do we want to continue? Yes, we do. We still want that behavior. Visited position contains current position. We continue. It's down here where things change. We're gonna want our nice little directions array to save us a whole lot of thinking. And here we're gonna return region. And then we're gonna iterate in all the directions. Don't care about height differences though anymore. So this is where we need to start to build up our perimeter and our area. So we're basically only gonna when we're looking for a region from any one given point, we're only gonna care about places where that place matches our current plant type, which means whenever we dequeue something from here, it should only ever be the same plant type as our starting position. So what we can do is we can safely say if we're hitting this point in our loop, we can safely say area increase or increase area. Actually, we can do that after we check if we've already been here. So, yeah, do that. So we'll add it, we'll increase the area, and we'll move on with our life. If we have already been there, we won't increase the area, we'll just move on. Current position is coming from the queue, which is fine. Now we need to actually start thinking through our logic here. So we're going to try to get our next position. If the next position is okay, so if the only reason we can't get the next position is basically because it's off the grid. That's basically what this is doing. So what does that mean? If something is off the grid, it means we've reached an edge, right? So if we're at letter F here and we're exploring and we go off, that basically means that's an edge or that's a perimeter, right? That's a side that counts towards our perimeter. So if this happens, we can say region dot increase perimeter. Then we can move on with our exploration. If it's not off the grid, if we actually do have a next position, I'm gonna make this bigger. If we actually do have a next position, we actually do have a next position, what do we do? If we actually do have a next position, then we need to make sure that our next position is the same type. So if new position dot plant type is not current, if plant type does not equal current position dot plant type, then we know we've also reached we've reached an edge of the region, a perimeter, or a side that should count as towards the perimeter. So we can again increase the perimeter and continue on. And then lastly, at this point, this is where we basically have gone, if we're exploring letter A and we're looking around it and we found another A, then all we want to do is add this to the queue of things to explore, and then continue on. And then let the search continue. So we'll say queue, positions to visit dot on queue, new position. It's not redundant. I feel like I missed something, but I think that's it. We just need to, hey, we're increasing the perimeter, and then we will call area again, since we on-queued a new piece of the region. When we process it, we'll increase the region's area. So let's return the total. And let's write some tests for our garden class here. But in our program CS, it should look like this. We should be able to say our result equals garden.from our input, which it doesn't like because we need to read all lines async. And then we can just say calculate fence price. We can say the total price, or the total cost to fence the garden is, and give it our result. Add a new class. This seems too straightforward that I feel like part 2 is going to punch me in the face. What do you want to call this? Garden test. The test method. Like async task. They gave us a few different example inputs here. So let's start with the smaller one. Make a new, we'll say public record calculate fence price test case, and that's going to have a string array, which is our input, and then int of expected price. Yeah, that should be all we need. Then we will have a public static enumerable of func that returns a calculate fence price, and we'll call this calculate fence price test cases. That, and we'll say yield return lambda, or a func. It's one of these. This will just be how do I want to do this? B, B, C, D, B, C, C, E, 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 C. And the total price for this, based on the first example, region AS price 40 for a total of 140. And we can eliminate that long name because we know the target type. Method, data source, name of, calculate fence cases, task, and we'll say calculate fence price. Oh no, yeah, calculate fence price. When called, it should return expected. Then we'll just all say is var result. A test case. Calculate test case. You can say var result equals garden dot from test case dot input say dot is equal, or no, calculate. Oh, calculate fence price, and we'll say await assert dot that result dot is equal to test case. All right, this will be a really good check to see if I just completely botched my pattern recognition here on how to solve this problem, but I'm pretty sure this is just another example of using oh man, 524 instead of 140. Okay, well, I'm doing something wrong, so let's step through this. Area 4, perimeter 10, that's right. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's right. But we're doing it. Oh. Because I'm walking the grid, so I'm searching for a region here, then I walk the grid and I search for a region here. So actually, stop. So actually, I think this needs to get lifted to a higher state. Basically, I need to lift this piece of state up. So we can, I guess we can actually make this part of the garden. And we can say private read only hash set of position. We can say this is visited positions. That. And I kind of want to be able to call this method. I want to be able to call it multiple times, right? And not screw anything up. So actually, let's not store this on the instance. That could get messy. So let's just cut this out of here. We're gonna lift that up here. And then when we're finding, we'll pass this in. hash set of positions, position. Which I think still makes sense to check here. Right, to check to see if we visited this or not. Yeah, we don't want to queue anything that we've already been to. Or does it? It is, well, we definitely have to check up here. We definitely have to check up here. We have to say if var position position, and if this is positions dot contains current position, we need to return. If otherwise, we can do our normal thing. So down here, I don't think we need this check. Well, let me just comment it. I don't think we need that check. Let's rerun this test. Okay, so now we've created an infinite loop. If visited position contains current position, we'll return because we don't want to search over regions. We do need this check. Yep, okay, cool. So yeah, because this kind of is important. It's important to check both places because we have to get started. And then we want to check this between times where we move in the grid, but we also want to check it when we're exploring each path. So what I'm trying to explain is, the first time I walk through this position's not in the visited, so it gets explored. But as I'm exploring, I want to say, oh, I've been here now, I've been here now, I've been here now. And I want to add that to the list of places I've been. And I want to check that so I can control this loop, so I can get out of it when I need to. Which maybe there's a better way because those checks seem redundant, but I think they're both necessary. In any event, our first test passes, so let's try with our larger inputs. So that's our first example. Now, in the second example, which is this example, it's 11:20. I'm really hoping part 2 is not a soul crusher. So 5-0 like that. See if my logic works, because this is the tricky one, I feel like. So we'll see how my logic holds up. So the second example, it's going to be 772. If this one works, I'll feel pretty good about it, honestly. And it didn't. Okay, 772, but found 556. So let's just look at the regions that we're finding. That is a pretty good proxy for what the problem is. So we should find an X. Plant type is O. We're saying it has an area of 5 and a perimeter of 12. But we're exiting too early because I think we're exiting too early because I'm basically finding an X and then breaking up this region. And I shouldn't be. That's another O. That's another O. An X, an X, an X. Yeah, I should just have one contiguous region, shouldn't I? So what am I doing wrong? I feel like I'm doing something where I'm exiting. So if it's not on the grid, then I increase the perimeter. If the current plant is if the next plant isn't equal to the current plant, I increase the perimeter and continue on, which seems right. I guess hold on, let me see. What am I missing? What am I missing? Debug. My first region I find is an O that has 5 in it and 12 perimeters. 5 plants with 12 perimeters. Then I should find another one which has area 16. 16 area. 30 perimeter. Then what do I find? Then I find an X. 1, 2, 3, 4. So those are right. It's the O's that are wrong. Because the O's O has a price of 20 divided by 36. So the 4X regions each have area of 1. Yes, that's correct. The region containing 21 type O's. So we are getting 21 O's. Is more complicated. In addition to its outer edge contributing a perimeter of 20, its boundary so the perimeter, I'm only coming up with a perimeter of 32. I do have 21 areas, but only a perimeter of 32. So which ones am I missing? Okay, so it's not readily apparent to me. So if we just walk this going up and down, this increases the area, this increases the area, then we say it should increase the perimeter. Why am I missing perimeters? Missing perimeter. Why am I missing perimeters? I feel like it's because I'm bailing too early on exploring something. So I feel like I'm keeping track of the visited positions too early. Um, what do I mean by this? I mean, I guess my working theory is that I need to move this visited position logic down here. Well, no. We can leave the add up here, because if we reach this point, we're definitely visited it. But I don't think we want to avoid checking the directions until we get down here. So, what would happen if I did this? And we check the new position instead of the current. We still increase the perimeter, I think. No. So, this current position, yeah. Oh man, what am I doing wrong here? I don't really want to have to step through this. Okay, let's not do things blindly. That is a mistake. This one works. This one doesn't work. So let's step through it. Yep. Okay. The current position not there, so we add it. The hell? That's weird. Excuse me. Yeah, so we'll step over that. We'll add it, we'll increase the area, and then we'll start looking in direction. So the first direction is up. That's going to be off the map, so we increase the perimeter. The next direction is down, which is going to be something we need to... Hold on, what? Why are we increasing the perimeter here? New plant type is this. These should be equal. Did I screw up the puzzle input when I... Yeah, I think I screwed... Gosh dang it. I think my solution's right. I think my test data is wrong. Which is why I'm getting two separate regions. Yeah. See, the first 5 here are zeros, not O's. So I'll bet if I run this now, passes. Oh, I shouldn't have manually entered it. I should have just copy and pasted it like I did the other 4 lines. Okay, let's try on the very last one, the big complicated one. I'm going to learn my lesson this time. I'm going to say yield return. Do one of these. And let's see, the price here is going to be there we go. And then they said the price is $19.30. Hell yeah. Let's go, bro. Okay, so let's go over to our terminal. .NET run project. It's the 12th day. It's called garden something. We give it the 12 days input. Hopefully it doesn't blow up. It runs fast. Hell yeah. Although I wasted 20 minutes on just bad test data. Okay. part 2. What time is it? 11:41? Okay. I will give this till 1 a.m. and then I'm going to get off. Famous last words. Famous last words. I haven't had any chatters tonight, though. Oh, whoops. Oof. I was just thinking about this today, but these committing to filming and streaming my solutions is going to get pretty hard come day 20-ish because we're going to be traveling to visit some family, and finding a place to like have like alone time where I can stream is going to be, I think, difficult. I'm either going to have to wake up super early or stay up really late. This should be a list. Okay. Let's see what kind of trickery the elves have for us. Fortunately, the elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. So each straight section of fence counts as a side regardless of how long it is. Consider this example again. The region containing type A has 4 sides, as does each of the regions containing plants of type B, D, and E. 4 sides. 4 sides. So it doesn't really, it just basically it's checking to see if it's a However, the more complex region containing the plants of type C has 8 sides. Using the new method of calculating the per region price by multiplying the region's area by its number of sides, regions A through E have prices 16, 16, 32, 4, and 12 for a total price of 80. The second example would have a total of 436. Here's a map that includes an E-shaped region full of type E plants. The E-shaped region has an area of 17 and 12 sides for a price of 204. So it has 12 sides because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The E-shaped region has an area of 17. This map has a total price of 368. It includes 2 regions full of type B plants, each with 4 sides, and a single region full of type A plants with 4 sides on the outside and 8 more sides on the inside. Be especially careful when counting the fence around regions like the one full of type A plants. In particular, each section of fence has an inside and an outside. So the fence does not connect across the middle of the region, where the two B regions touch diagonally. The elves should have used the Mobius Fencing Company instead. Their contract terms were too one-sided. The larger example from before now has the following updated prices. So what was he saying here? Be especially when counting the fence around regions like the one full of type A plants. In particular, each section of fence has an inside and an outside. But it says it has 12 sides, so let's see how he got that. So it's 1, 2, 3, and 4. Then 5, 6, 7, 8, 9, 10, 11, 12. So the fence does not connect diagonally. Yeah, I see what you're saying. He's basically saying, hey, that these all count as sides. Okay. So public int sides together, private setter. Sides. Calculate fence price based on perimeter. Then public int calculate fence price based on what? Based on size. That. Okay. So how do we determine a side? So let's go to the smallest one. So obviously a side occurs when I have to change my direction, basically. So when I'm increasing the perimeter when I have this condition, A checks here, so that's a perimeter. A checks here, that's a perimeter. I basically have perimeters. I'm trying to think of if I can use something I'm already keeping track of as a proxy for the sides, is what I'm thinking about. Um, or can I... let me look at one of these regions really quick. Ugh, what is this guy? It's an A. Okay, so this is an A. We have 4 positions that we visited. Is good. So theoretically, we have all the positions that make up a region that we're keeping track of. It's good. But I think that list is going to keep growing. And what does C look like? C looks like this. So, like this means I have a side, right? So if I go from 0 to 1, to 3 to 5, if I go up by 1 and the Y doesn't change, that's a long side. Let's have a box. Yeah, that seems too difficult to work back from. So sides have to share the same. Like this is one where we'd have to be careful, right? Because these need to share the same. They have the same Y. No, they have, yeah, same Y, different X's. That's a side. Cute. Yeah. There's gotta be a way to leverage. There's gotta be a way to leverage what I'm already doing. God, I hate when part twos are like this. When they just freaking stop me in my tracks. So how would I know I've got to a side, right? That's the question that I'm trying to answer. And intuitively, I'm thinking, um, intuitively, I'm thinking, um, so another idea I have is, first of all, this music is just not doing it for me. Another idea I had was basically keeping track of the literal sides. So let me think about that. So if I knew that this has four sides to begin with, um, if it's adjacent, I can decrease a side. So now it just has three. Um, Yeah, that's tough. The number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Each straight section of fence. So, what defines a straight section of fence? So here's a straight section of fence. Here's another straight section of fence. And here's another straight section of fence. But only the sides that touch B is a side. The inner side's on the side. So when we get to this is where we would encounter B. Or let's go up here. If we get here, then we know there's a side here. If we get here, we know there's a side here. But we don't want to increase any count because it's the same side as the previous. Man. I don't know, man. I'm kind of stumped. I feel like I need to scroll some TikTok and like disassociate for a little bit. Cause I'm feeling kind of lost on this one. The path seemed really clear on the first one, but now I just don't understand. I mean, maybe I just have to use a completely different approach. I'm not sure what that would be though. Maybe I keep track of. I keep going back to like. I keep going back to this idea of like a change of direction. So, if I had all these squares, if I had all these squares, um, and let's just say if I looped over all these squares, and there was no change of direction, well then I know I have I have four sides. For something like this, though, if I loop over them, kind of like, okay, well now I know I have some sort of weird change of direction. Where I could say that's a straight section of fence, so that's a side. But that actually contributes 1, 2, 1, 2, 3, 4 sides. This contributes 1, 2. This contributes 1 side. This contributes 1, 2, 3 sides. Ah, boys. Okay. I kind of have like a um. So if a side is we can define a side of a region by um well, like up here, a a meets with D, so that's a side. A meeting with A is not a side. um However, so does this, right? So if we use that logic, all four of these would technically count as sides. Um, but it's duplicative. So we have to have some way of identifying the sides, but we have to have some way of not double counting sides. So how many sides does this have? This is 1, 2, 3, 4 sides. Type A, type C has 8 sides. One, two, three. 2, 1, 2, 3, 4, 5. How is that different from perimeter? So a perimeter is just checking to see if the thing next to it is right. Hey, are you the same as me? No. Well, this is a perimeter, but it's also a side. However, on the next one, the left doesn't count as a side because we already have one above it. Okay, so maybe that is that a pattern that we can follow? So if I'm going down, we get down here. We get down here. Current and next are same. Man, I'm so fucking lost. I'm not sure how to do this, unfortunately. I keep thinking there's some way to like traverse the region. Is what I guess I keep thinking. Okay, if I know all the paths that make up the region, then I can start here and say this has 1, 2, 3 sides. Then if I move to the next spot and I say, okay, the next spot, So if I had our region positions equal the list of positions that region add position. Yes, that would give me all the positions in a region. But how would that help me? So if I had A, and I said, um, I basically say A has three positions, or A has three sides. The first A has three sides. The next A contributes 0 sides. Why does it contribute 0 sides? Because I have then the next A contributes 0 sides, and then the next A contributes 1 side. If I have B, first B contributes 3 sides. The next B contributes no. This B actually contributes 2 sides. The next B contributes 1 side, right? So this B contributes a side here, a side here. This B contributes a side here, and then this B would contribute a side here. Same thing with up here. Contribute a side there. Contribute a side there. Contribute a side there. And contributes a side there. if I think of it like that, if I think of it like that, then when I get to this B and I say, hey, obviously it can't contribute a side in that direction, and I say, can it contribute a side in the upward direction? And I say, no, it cannot. And it cannot because this would have the same y coordinate as an existing e coordinate. So loop over all positions in a region. At each position, check, can I add side? I can add a side if the next position is not the same plant, and if there isn't already a side that contains that X or Y value. So what I mean by that is, if we call this, if we call that side -1 or 0, -1, and if we get here and we say, can I put a side at 1, -1? No, you can't, because we've already established that there's a side running along -1. Let's see if that same logic works for I mean, does that, can I look at this? Can I figure that out just by looking at these two things? So if I'm looking at the current, I'm looking at the next. If I say next is the same, and I say I think maybe I see a way to do this with what we already have, so let's go over. Okay, let's look at the more complicated one. Let's look at C. The C looks like this. So if we were to follow this logic, we would say, yes, I can put a side there. Yes, I can put a side here. Put a side here. This I can't put a side here because I already have a side there. Because we have the same, this would be -1, -1, 0. This would be -1, 1. But this one can contribute a side here because I don't have anything there. Then this guy can contribute a side here. I don't have anything there. This one gets to be another side, so this actually will turn into 2 sides. And this will turn into 2 sides. And there'll be one more side down here. So it'll be 1, 2, 3, 4, 5, 6, 7, 8. So the coordinates of these sides would look like this. They would look like 0, -1, -1, 0. They would look like 0, 1. Then they look like let's see, 0, 1, 2. These like 0, 2. That's this guy right here, 0, 2. Then this guy is gonna look like he's gonna contribute 1 here, which is gonna be again, if that's the same position again, zero, 1. So that's a duplicate. But that's not really helpful. I'm closely approaching my deadline. I said I would give this till 1 a.m. haven't wrote any code in the last 35 minutes. And that's because I don't understand the problem. Because the logic here is really similar to perimeter. It's just it's almost like I don't need the coordinates to be absolute to the grid, but absolute to this thing. Not absolute, relative, right? Because this is okay because my side is here, and it's okay to place it again because the side is now horizontal. So thinking about that again, right? What I'm saying is this is up. This is the top. This is a left. This is a down. This is a 0, 0, 1. Top is here. Then left. Oh. Then right. Then this is down. Then this is up. Then this is the 0, 1 is okay because we have a 0, 1 right and we have a 0, 1 up. Those are unique. Then this guy is 0, 1, 2, 1, or 0, 1. This is 2, 1 moving right. Then we have this guy, and this guy contributes a 0, 0, 2, but it's going left, so that's okay. So the direction could be used. Interesting. Okay, that's somewhat unique. So keep track of all the region positions. And then once I have all the region positions, I say for each bar position and region positions, or okay, let me hold on. So what am I gonna? I'm gonna have a new thing called position, not region. We're gonna call it record side. Say int x, y. Well, actually, we could say a side has a position. It has a direction. These are records, so they're going to compare by value, so that should be fine. Then I could say sides equals well, actually, going back to my notepad, I just thought of something. Where's my other notepad? So, well, like here, right? So this is a different. It's a different. Um, it's a different y value, but it's the same x value going in the same direction, right? So this would be if I tried to place a side here. I would be trying to. I would be basically trying to say, that's top, left, right. I'd be basically trying to place something here and say 0, 1, 0. that's negative. So it would be -1, 0. Right? And -1, 1. -1, 1 going left. Which would be a violation, or I guess it would just mean, hey, that we already have that side counted. So let's start by just trying to keep track of a number of sides. So we know we're going to be in here where we're increasing the perimeter. We also need to do some other checks to say, okay, these things don't equal each other, but actually, never mind. We need the positions. Yeah, so oh, let's see. Try get next position. If next position's off grid, still returning it. So what we can do is we can say it's off grid. That's fine. We still need to check and see if so. What do we say here? We say if direction is direction dot up dot direction equals direction dot up. Direction equals direction dot up. so let's say we're here, we go up. That point, we're basically, the direction we're at is -1, 1. Or no, sorry. The direction here is 0, -1, up. And then on the next one, it's going to be 1, -1, up. So, if the direction is equal to up, or the direction is down, dot direction equals direction dot down, we need to say, then we need to say, I'll clean up the nesting, but if direction is up or direction is down, then we need to say region, not region positions. We actually should call this region sides. Say sides. Side. And we should actually say if region sides dot any if any side s dot direction equals this direction and side dot position dot y equals new position dot y, then that would mean it's a duplicate side. So then the inverse of that would be if all do not equal and s positions do not equal, then we can add a new position and and then I think the other logic here is if direction, I guess we could actually just say else we'll make it explicit. If direction is left or direction is right and none of the region sides have the same direction, this angle X. Add it. And let's do that. We're also going to do that same logic. Actually, let's move this up. So I should be expecting this to just have 4 sides if my logic is right, or if I'm even on some reasonable. Okay. Now B, what should be? B should have 4 sides as well. Yeah. The next region. B should have 4 sides. D should have 4 sides. E should have 4 sides. Oh, hold on. How many sides did C have? The C only has 4 sides. What am I not taking into account? Okay, so let's look at C. I've gone over my deadline. Hey, Pop Fletcher Live. I'm actually, I'm not really building anything. I'm doing Advent of Code. If you ever heard of that, it's like 25 days of puzzles that are all Christmas themed. And right now I'm trying to work on solving part 2 of day 12. Part 1 went well. Part 2 is giving me a little trouble. Just trying to work through it. But I also want to go to bed. Ugh. Okay. Okay. Oh, I think I might know what I'm doing. I want this logic to run. No, I do want it to run on the edge. But let's look at my logic again in that new context. Oh, nice. Yeah, I think Advent of Code's super popular this time of year. Everyone's trying to do it. I mean, it's fun. This is the second year I've done it. I had a lot of fun last year. If you don't have a like, I don't have a strong CS background. I didn't go to school for biochemistry. My degrees in, or I didn't go to school for computer science. I went to school for biochemistry, and so a lot of the problems are they're kind of leak code ish, right? So they're kind of pretty heavy on like the data structures and algorithm side of things. So it can be. I think it's kind of fun because every year I feel like, or every almost every puzzle, I feel like I walk away learning something a little bit more um, about different algorithms and the ideal data structures to use. So yeah, it's fun. It's probably not as good of a time as actually building a real project, making something people actually use, but it's a fun way to practice to get better. C plus plus, huh? Yeah, I've never actually written any C plus plus. Uh, Okay, so this first time through, I would expect it to give me 3 sides. Yeah, 3 sides. A, B, and D. A, B, and D. Okay. So then the second time through, I step over this. The current position should be 2, 2. So that's 0, 1, 2, 0, 1, 2. That's this guy. And I would expect that to contribute 1 new side. So let's see if that's true. Yep, okay. So that gives me 4 sides. Now, when I step over, this is where things go wrong. So I step over this. This 3, 2, so we're over here. 0, 1, 2, 3, 0, 1, 2. So we're over here, we're on this C. So this, I would expect it to contribute 1, 2. So let's see what happens. So we'll step over. Okay, the first direction is going up. So this should give me 1. So direction is up. So we enter here. Now, if all basically all x's don't equal, or if all directions don't equal the current direction, well, that's never going to be true because there's definitely an up already in here. So we're going up to the same spot. Okay. So the question I'm asking is more if this direction and all let's see what that does. So does not equal the region and the positions are the same. That's really what I'm asking. Basically saying this is okay. I want to participate, but I never got past the basic. Who knows though? Maybe I'll do. Yeah, I mean, I did Advent of Code last year. Um, I did it for the first time last year, and I made it to day like 15, part one, and then I just kind of ran out of steam. Um, I mean, I think it's more about just trying because, like, I noticed that I've gotten better at recognizing like different patterns between last year and this year, right? And that's a win in of itself, you know. Um, like I've been trying to solve this now for 3 hours, and there's people who solved it in like 20 minutes. So you're really just competing against yourself, you know. It's just another way to get practice and try to improve your skills. And it's it's fun because it's Christmas themed, and for me, most of the time I work on projects. I try to build stuff, typically web development related stuff, but this is a nice break from that, kind of a change of pace, a different style of programming, different style of problems. So yeah, it's just, change of pace. I would say if you want to participate, if you want to try it next year, go for it. There's no skill level you have to have, and if you just do one day, so be it. Maybe next year you try to do 2 days. My goal is to try to get past. Since last year I got stuck on day 15, my goal is to get past day 15 this year. If I get to day 16, then it's a win. Let's try this again. Still just one. It should be 4. I think all is wrong. The wrong thing I want to check. I think I want to say if any. If any. Any. If any of that. They have the same direction, same position. If any, then any is false, then add. I said I was gonna stop after. Yeah, so 10 is just doing the same thing as a perimeter. Um, yeah. Which is why it's not really about the same s position dot x. I just care about that particular direction. They just need to not share the same direction and not share the same value in that particular axis. So let's see, debug. Okay, that's promising. 4. Okay, so now we need to get to B. Just 4, which is correct. C is 8. That's correct. And 4. Okay, so let's see. Is there any way to clean this up? I honestly don't know. So let's try to go to the next test, which is this one. So here's a map that includes an E-shaped region full of type E plants. Okay. Well, real quick, let me just look at this one. So this one should have 1, 2, 3, 4, and then it should have 4. So 4, 8, 12, 16, 20. This should have 20 sides. Or at least that's what I think. Yeah, debug. No, it only has. Stop. That's the wrong one. This is the one. What's I've never written any C++ before. What's the tool chain like for C++? It got good debugger, good is the dev experience good? So that's saying it should have 12. Seven, 8, 9, 10, 11, 12. Okay, so let's just say I'm gonna copy this out and say yeah, just gonna say sides. Yeah, just increase the count. I'll just say something like region dot increase sides equals region size dot. Then let's have something called the F2 calculate fence price by based on perimeter. Calculate fence price based on sides. Based on sides. Then let's add some tests for the new. Calculate fence price based on perimeter. Well, actually, that's fine. It didn't say how many I should have. What do I say? Public. Static I enumerable of bunk. Basically going to be the same thing. Here, so here. Sides. They gave us this input instead of this one. Okay, so this. $236. $236. This should be 80. 80. Original puzzle. Puzzle 6. They also gave us another one. Play. This is 368. I was feeling good about this for a second, but now I don't feel as good. I think this first one will work. A method to use that. Oh, does this one run? That doesn't run. Vector result to be 80 but found 8. This is going to be close this tab. Okay. So 80 works. 368 works. What about this one? Doesn't work either. Okay. Let's see. Kind of wish. Okay, so let's look at the big guy. Actually, let's look at this one. Which one of these? Which ones fail? 1206 and 236. So 236 fails. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 12. Oh, 12 sides. Why does it have 12 sides? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why am I only getting 11? 1, 2, 3. Oh my god. Oh. 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Okay. Let's see what I'm coming up. Sure. So I'm missing 3. Missing 3 sides. Let's walk the E's to figure out where we come up short. Let's see. This is painful, but this is all you can do when you get to a point in a problem where you think you're on the right path and you just kind of have to think about the specifics of each case. Okay, so the first one's up, so that should add an edge. I should get one, right? I should get one side out of that. Now the next direction is to the right. I shouldn't get any sides out of that. Next direction is to the left. That should give me a side. Next direction is down. That should give me nothing. Okay, so that's right. Now we're going to go to the next E, which is down. This should give me one more side. So at this point I have this side, I have the top side, and I have this side. So let's step over. First one is up. That should not give me a new side. Next direction is to the right. That should give me a new side. Hold on, why didn't the... Moving to the right? Should have given me a side. Direction to the left. No, this is going to the right. This should give me a new one. Nice. That's what I would expect. Okay, so I have 3 at this point. I have top, left, and then this inner one. Over. So now I'm looking at 1y0. So I'm looking right here. So this one should contribute nothing. You give me no sides. What are we looking at now? Current position is yeah, it continues. Already looked at it. Okay, now we're x, y2, so we are down at this one. What sides do we have? We have -1 and -1, that's fine. We have x1, y1. We have that going to the right and going down. So xy, x1, so 0, 1, 0, 1. Okay. You know, this actually I think would be a lot easier to just diff what I have versus what I should have. So expand this row. Oh. So I should have here. So 0, -1. Yep, that's that top side. -1, y0. That's this side. 1, 1. Up, 1, 1 right. That's this side. So that's this guy and this guy. Y. Yeah, 1, 1. Yeah, so I have top, left, 1, 2, 3, 4, 5, 1 dash x1. Here, 0, 1, 2, 3. This guy. I gotta visualize this. Copy. Notepad. So I'm saying I have an edge here. Saying I have one edge here. One edge here. And I'm saying I have x1, y1. That's here. So x1, 0, 1. So that's here. I'm saying I have 3 here, which is correct. And then I'm saying 1, 3, which is 0, 1, 2, 3. I'm saying I have 1 here. And I'm saying I have 1 at x, 0, y 5. So 1, 2, 3, 4. Then I have 1 here, which is correct. Then x5, y0. x5, y0. That's 1, 2, 3, 4, 5. I'm saying I have 1 here. Then I'm saying I have 1 x at 1. So let's see. 0, 1, 2, 3. And I'm saying I have 2 here. So this side, so we have 9, right? Yeah, we're saying we have 9. We're not getting this edge. We're also not getting this edge. And we're missing an edge here. We should have 1 here. We should have 1 here. We should have this is current. Current should have 3. 1, 2, 3, 4, 5, 6, 9, 12. So we just need to find out what's happening when we hit those cases. So let's investigate. Let's investigate this one first. So that is going to be what? 0, 1, 2, 3, or 1, 3. New position equals new position 1, 3, x. Okay, so what's our current position? Our current position is 0, 3. So we're looking at 0, 3 is this guy. So I would assume it's going to hit one of these lines in here. It was moving right. Oh, I think I see why. So it's saying, oh, move right. Do I have an X there? Yes, I already do. Crap, does that blow up my whole thesis? That's the same it's the same reason this it's the same reason we don't find these two either. So what could we do to further So this is actually okay to count this as long as the current position isn't the same. Okay, let's try that. So as long as the position so This is the this is basically position on one side, position on the other side. So for lack of a better they're actually going to get swapped for current direction new. Then where the question we're asking here is new or I'm actually gonna change that. I'm actually gonna say maybe we can say in region position, and then we can call this out of region position. And this can be if out of region position, and if current position current position equals s dot in region position equals $36. Never mind. Not equal. Again. Stop. So a side essentially consists of a position, another position, and the direction. Right? Is it separating it top down? Is it separating right left? And what I'm saying is basically what I'm trying to express is I'm trying to say this is a valid side if we're going from this position to this position. That's fine, right? If we're going from left to right, I'm going here to there. Oh, yes. So it doesn't work because then it allows these to be okay. So the question is, why are they okay? Yeah, it's like, why are they okay? I don't know. It's 2 a.m. Holy shit. I might have to call it quits on this. Yeah, 4 hours. Yeah, I'm gonna have to call. I'm gonna have to call it. I'm making this way more complicated than it needs to be, though. There's some super simple, elegant way to do this to figure out whether or not you're in a contiguous side. I still think maybe there's something to maybe there's something to iterating over these. That's contributes. Then you get to here. And yeah, that's, yeah. But still doesn't solve this problem. How do I know that it's okay? I guess I would know it's okay if I check directly above. Yeah. And that would work up here too, right? So if I'm here, This is an edge. This is an edge. Or this is a side, and this is a side. Now, if I come to this guy, I can say, hey, this is a side up here. But only if there wasn't one preceding it. There was like a gap in the fence, right? So like in the case of these guys, I could say, oh, or in the case of this guy, I could say, oh yeah, you're right. There's already a side that's in that direction and in that column, but the person right above you is not the same as you. So then that makes this okay. Same thing here, where I can say, what can I say? Current position, moving right. And over here, what I would say is, oh, current position moving right. Yeah, I'm not sure how I would know that this is okay. How would I know this is okay? So what's above you is not the same. Yeah, I guess if you're off the grid, then you want to check the current. But if you're on the grid still, then you check the next. God, that's super messy. Okay, I'm gonna come back to this. See, I've been at this for 3-4 hours now. I'm on day 12, part 2. I have part 1 solved, but part 2 is proving elusive. So I'm gonna put this down for the evening, and I'm gonna come back tomorrow. Maybe try to do part 2, continue on part 2 over lunch tomorrow, and just try to avoid falling multiple days behind on this stuff, because the 13th day puzzle's already out. Yeah, anyways, if you're watching, hope you have a good night, get some sleep, and I'll see you again. Good evening. We are back once again to try to conquer part 2 of day 12. I realize it's day 13 and I've fallen behind, but I've spent the better part of the day thinking about this, and I think I've figured out a path forward. So let me explain my ID here. Let me get my little scratch pad. So this was what we were working on last night. And basically, part 2 is all about trying to figure out the sides of your region, but and not the perimeter, not each individual side, but the actual like straight fence. So you can kind of think of it like if you were to trace the area here. So if I go to, so we have to figure out this side, then this side, then this side, 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 and this side. There's 10 sides here. Now, if we go back up to the top, up here, there's something interesting that I noticed that I think can change how we approach this problem, and it's kind of the unlock, or I think it's the unlock. So if you notice, right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 perimeters. But we only have 4 sides. Another proxy for sides is corners, right? So for every side you have, you've got an equivalent corner. So like in this very simple example, it's a box, rectangle, so it has 4 sides and 4 corners. Even with the more complex shape, though, it still holds true, right? So if I was to draw the sides here on this one, we would say 1, 2, 3, 4, 5, 6, 7, and 8, right? So if we count the corners, we also get 8. So corner, 2, 3, 4, 5, 6, 7, and 8. So my thinking is, if we can find corners, then we know we have the equivalent number of sides. And I think corners is going to be a lot easier to deal with because we can essentially walk all the positions in our region and basically look for corners, right? I think this is going to work. Because I have yet to think of a way to figure out how to walk and keep track of where we ended up last night. We can just kind of go back to where we ended up last night. I was trying to. Oh, I cleaned it up. Sorry, I did clean that up. What I was basically trying to do last night was I was basically trying to figure out if I was basically trying to keep a list of sides, and I was basically trying to keep track of, do I already have a side that's basically, do I already have an edge there, right? Do I already have an edge between these two positions in that direction? And that just became, I couldn't figure it out, for lack of a better explanation. So, let's try to do this corner idea, because I think it's going to be much more feasible. So, the first thing I'm going to do, what am I going to do first? So, to go back to what I was talking about, do something here to identify how many sides each position contributes in a region. Yes. But I'm not going to try to figure out how many sides are contributed per position. I'm just going to figure out if a position contributes a corner to the region or not. So the first thing we're going to do is we're going to go down here to our region class, and we are actually going to, instead of keeping track of sides, we're going to keep track of a list of positions. So these are just every area of the graph that has the character plant that we're interested, or the plant type that we're interested in. So this is going to be positions. It's just going to have a getter. And we can actually also, well, we'll come back to that. So we're going to have a position with a getter. It's going to be equal to an empty list. And then instead of increasing size, we're just going to say add position. And actually, I'm going to make the position a hash set, because we only care about unique positions. Or we need every position in the region should be unique. So positions dot add, position. This is making sense in my brain, but I have this sinking feeling in my stomach that I've made this too simple. Yeah, so we're going to add our position, and then this is actually going to be more complicated than this method. So I'm just going to make up actual body, return 0 for now. And so now what I want to do is, as I'm looping over here, I just need to keep track of the positions that we've gone to. So, oh, I guess I've already done that here. Oh no, this is left over from last night. I was trying to keep track of the positions. So we can get rid of this, because we're just going to add them straight to the region. God, why is that so loud? Too loud for me. I don't know how loud it is for you guys, but it's too loud for me. So we'll say region dot add position, and then it looks like I also, at some point, I screwed up adding my position to my visited positions. And then the first thing I see that I can change is I don't need this increase area method anymore, because I can just use the positions, the number of positions, as my area. So I'm going to get rid of that method. This is just going to be an expression body that says positions.count now. And we can get rid of this. Leave that. Okay. So now that I'm keeping track of my positions in my region, I can basically get rid of this. I don't need to do that there. I need to fix some of my tests though, because I've broken some stuff. I thought I did. I guess not. Let's go ahead and add a test to our region for adding a position, just to make sure that works. Not that. Test. Public async task. Add position. When called, it should add a position. So we'll say var region equals region A, and then we'll say region dot add position. Just give it an O, A, 0, yeah, 0, 0. And then we'll say await assert dot that region dot position is equivalent to new hash set position of the constructor. Put it there. Then I can also say await assert dot that region dot area is equal to okay, tests. We'll close this tab. Okay, all those tests passed, which is good. These tests should all fail, right? Yeah, those are just failing. So should they be failing? Well, actually, they're going in a loop. So how did I create an endless loop? Because what I want to be adding here is current position, not position. Yeah, those all fail. Okay. So this is where we're going to start to work on the idea I had. So we have our region. And in our region, we should be able to say something like var sides equals, or actually, we'll call them var corners equals find corners. And corners is always equal to the number of sides. So basically looking for corners is like a proxy of looking for sides, because where a corner is, there's going to be sides that meet. And then if all your sides connect, then for every corner, you have an equivalent side. Right? Because the corners are essentially termination points of sides. Yeah. So this is where we have to find the corners. So what do we do? And then we're also going to not return 0. We're going to return corners times our area, like that. And then we're going to need a method that's called private. It returns an int, and it's going to be called find corners. And we're going to need some sort of count. We'll just go ahead and call this num of corners. Excuse me, and then we'll return that. And then we'll for each over our positions. That. And then in here is where we'll check for corners. So if we look at some of the examples they give us, there's some really kind of straightforward ways, right? We can check for corners. So let's look at this. Let's look at this shape up here, right? So the easiest way is if we're looping over each of the positions in here, is basically to just look in each direction, right? So we look up, we look left, we look right, and we look down. If I look up, right, so we can kind of picture this. If I'm at A and I look up and I don't have another A, and I look to the left and I don't have another A, that makes this contribute one corner, right? If this is true right here, then there's one corner, and that corner goes from here to here, right? So that's my corner. If there's not another A to my right, right, then that would be another corner. So essentially you have these combinations of left up, left down, right down. So if those combinations are present, meaning there's no other plant type, there's not the same plant type in those positions at the same time, we know we have a corner there. And we should be able to express that through some code. So what should we be able to do? We should be able to say something like var has neighbor, and I'm just going to use the term neighbor. Neighbor meaning if I'm an A, then there's an A above me, meaning my neighbor is A. If the plant above me is not the same as me, then it's not my neighbor. And I also only have to look for these neighbors within the confines of the region, right? So if I don't find that neighbor in the region, then I know that the thing above there is not me, right? It's not. I know it's not me because it's not part of the region I'm a part of. So we'll call this has neighbor above. And then we should be able to call some method that basically answers that question. And we should be able to do this for every direction, right? Has neighbor above, has neighbor below, has neighbor left, has neighbor right. So let's go ahead and build that method. So this would be another private method. We'll call it private has neighbor in direction. And that's going to take a direction. that's going to take that's going to take a position. Okay. So in here, I should be able to say has neighbor in direction. And in this case, I want to look up. And I want it to be from this position that we're currently on. Just need to return the pool. So what do we do here? So if I was, let's use another puzzle, right? So let's just say I'm here on this C, right? And I'm asking the question, do I have a neighbor above me? I don't really need to check the grid. I don't need to know about the grid. I just need to know about the region. So what I want to do is I want to figure out what the position is above me, and then I want to see if that position is in my region's list of positions, right? So I'm going to see if this position, no, I'm going to see if the next position, right? So I'm going to calculate the next position using the direction and the position given, and I want to see if the next direction or the next position is in my region. That would make it a neighbor. So we'll say var next position equals position dot so I have this try get next position method, and I have that so that I can check if things are off grid or not before I try to index them or access them. In this case, though, I don't really care if the thing's off grid or not. I just want to get whatever the next position would be, even if the next position has invalid indexes. Because I'm not actually going to use those indexes to access the grid. I'm going to use those indexes to look for other positions, if that makes sense. So I'm going to create a new method for my position class that's called public position get next position, in which this case I just need a direction. And then basically just going to do what's happening down here. Return this. And I'm just using a period as the character or the plant type because, again, when I calculate the next position this way, I don't really care that it's even a valid position on the grid. Yeah, I don't really care that's a valid position on the grid. So I'm going to inline these to make it a little bit easier. That I can actually make this much less lines. That. And then down here I can actually just say then I can actually use that new method and just say what can I say? Oh, I can just, yeah, I can just call that and just say get next position direction, that. And then I can just say here, I can say next position dot y and next position dot x, like that. What are we complaining about? Okay, so now instead of this, will be get next position, and we'll pass in our direction. And then the question I want to ask here is I want to say return positions dot any. Right, so basically it's saying, hey, does any of the positions in my region match the calculated next position? That would indicate that we do in fact have a neighbor in that particular direction. So this would be p p dot y equals next position dot y, and p dot x equals next position dot x. And I'm actually going to switch those. I'm going to say y over here and x over here, just to keep with the whole left right xy thing. So now we can basically answer that question over and over again, and just change the direction we're giving it or the position we're giving it. So now we should be able to ask it 4 times, and we'll say, do I have a neighbor above? Do I have a neighbor to the right? Do I have a neighbor below? Do I have a neighbor to the left? So has neighbor to the right, has neighbor below, has neighbor to the left. And then at this point, we just want to increment the corner count every time we have the right combination that indicates a corner. So the case we're specifically looking at is this case, right? So if we were to add a comment here, we're looking at this case, right? So we have x, x, call it r, x, and or no, x, right? So in this case, these are all the ways that a corner can be formed, right? So if I am at a particular position and I say, okay, do I have a neighbor to the left of me? Do I not have a neighbor to the left of me? And do I not have a neighbor to the right, to the top of me? Well, then I know there's a corner there. And then we ask the same thing on the other side. We ask the same thing on the bottom on the other side. And then the same thing on the bottom on the other side. So what does that look like? It would be if has neighbor. I'm going to do this. I'm going to do right, up, down, and then left, up, down. So I'm going to say if it has, if has neighbor right is false, and has neighbor above is false, then we have a corner. Excuse me, I'm going to rename this number of. So that covers this case. Doesn't have one to the right, or no, that covers this case. Doesn't have one to the right, doesn't have one above, corner. Yes. Yep. Then we'll say if has number to the right is false and has neighbor below is false, then we know we have another corner. So you can kind of see the combinations, right? We're looking here, we're looking here, we're looking here, we're looking here. And then we can duplicate this logic, and we can just say has number left is false. Has number left is false. Yep, just like that. And so now, based on that logic, right, this is a corner, right, because it doesn't have one to the left, it doesn't have one above. This is a corner because it doesn't have one to the right, it doesn't have one above. Same thing here. This is a corner because it doesn't have one to the left and it doesn't have one below. This is a corner because it doesn't have one to the right, it doesn't have one to the bottom. So that's 4 corners, and this thing has 4 sides. Now, this shape, though, the C shape, doesn't quite follow that, right? So this C has 2 corners because not to the left, not above, not to the right, not above. This guy right here is interesting. Because there is a corner here, right? And so these are interesting corners because they're, what would we call this, convex, right? So a corner can be like this, but a corner can also be like this, right? So we kind of have this like I'm gonna call it concave versus convex corners. Yeah, I mean, so concave curves inward, convex curves outward. So if I was describing that, I would say this is a convex because the corner goes out, and these are concave because the corner goes down. And so this has kind of a mixture. And right now we're only dealing with concave is what we're checking for. Because this wouldn't catch, this logic would not catch this corner, nor would it catch this corner, right? Because this is up, it has a left, it doesn't have above, but it does have a left. This has above, this has to the right, so it wouldn't catch it. So we need to count for this. So let me add another diagram here within the comments, because that helps me make sense of a little bit. So we have this diagram. You can have 4 corners this way, but you can basically have the inverse of this. Which is gonna look like the inverse of this would look like this. right? So now if we're in the center here and we're looking at this guy, now the questions we need to be asking are, does it have a right, and does it have a top neighbor? So does it have those neighbors? And if it does, I then want to look and see, okay, does it have a neighbor here? Because if it doesn't, if it has a neighbor above it, has a neighbor to the right of it, and if it doesn't have a neighbor diagonally, then it's a concave corner versus it's creating a concave corner, not a convex corner. So we're basically going to have very similar logic to this, only inverted a little bit. So again, I'm going to look at this going left, right. So I'm going to say bar, because I'm going to need these positions. So if this is my current position, I'm going to need to look at left and I'm going to need to look at right to figure out if there's anything above them or below them. So I'm going to call bar next position, let's say right, and then we can say position dot get next position direction dot right, and then we can say var next position left. Oh, hey guys, what's up? I didn't see the chat, sorry. Oh shit, .NET. A .NET language I know, yeah. People are out here using F# and stuff, and yeah, I don't know F#. If it hasn't been answered, much easier to write your own game without an engine. This sounds like you need some recursion, but good luck. Okay, so I was working on this last night, and I got stuck on it for like 4 hours. I solved the first part in like an hour and 30-ish minutes, and then for the last 2 hours of my stream, I basically just sat here like this and wrote very little code. But I thought about this all day, and I'm pretty sure that this will work. It's very iterative, but it should work. Yeah. The other question there. Hi, I have a question. What engine is easier to learn for total newbie, UE5 or Unity? Well, I've never worked with UE5 or Unity, but I know C#, and as I understand it, Unity uses C#. So I would probably push you towards Unity. There's an engineer I work with at work who has been building games in his free time, and he uses Unity and loves it. Has nothing but good things to say about it. But sorry, can't give you any really like pointed advice because I haven't done any of it myself. Oh, and I saw what Not Me Don't Worry said about writing a game without your own engine. That's kind of an interesting way to start, right? Like I've written web-based like JavaScript games like Snake, and it's probably still deployed, I think. But like, you don't necessarily have to. Yeah, you don't necessarily. I mean, you could just get started, right? You could use something if you haven't ever wrote a lot of games before. You could start with something like this. which I'm not sure how laggy this will be. But it doesn't, you could start with something like just a JavaScript based game of Snake to kind of get a feel for game loops and rendering and that sort of thing. And then move to something more sophisticated. But yeah, that was a fun project. Games are fun. The game loop kind of like sometimes it feels messy because you're like it seems like you're trying to jam pack a lot of things all happening in this cycle that's just endlessly running. But from what I understand, that's kind of like the nature of the beast. But game development is definitely not my wheelhouse. Okay, back to the problem at hand. So we're gonna get the next position to the right, or next position to the right, and then the next position to the left. And the whole reason we're getting these is so that we can do the check, right? So the first question we'll ask is we'll say, if I'm at this position, the middle position, and I look to the right and I have a neighbor, and then if I look up and I have a neighbor, the next question I need to ask is, do I have a neighbor here in this corner? And so the way I'm going to get to that corner is by using the next right position and then asking if this position has a neighbor directly up, right? So it's essentially, I mean, we could do something that calculates just the diagonal, but I think this will be fine for now. So we'll say if has neighbor right and has neighbor above, and so this is where we're going to call the same functions that we called up here, but instead of passing it the current position, we're going to pass it the next position to the right. So we'll say if this is true, then we'll say, does the next position to the right have a neighbor up? So we'll say has neighbor in direction up, and then the position we care about is next position right. And we need this to be false. We need it to not have a neighbor. If that's all true, if all those things are true, then that's a corner, and we can increase the number of corners. And then what we can do is we can just repeat that same question. And the only thing we'll do different is we'll say, does it have a neighbor below it? And is there a neighbor in this position? Right, so we're going right and down now. Say if as neighbor. So we're just going to duplicate these lines. And we're going to do the same thing, only now we're looking left. Say has neighbor left. And this is next position left, not right. I think that should find us all our corners. Then we're returning those corners up here and then using that to calculate the area. And now we just need to rerun these and see if they work. I put these test cases in last night when we were trying to do it different. So let's see if they work. Let's go. So all those pass. That's awesome. Man, I was just last night. I was stuck here for so long, and then I thought about this all day long at work. Um, I can get rid of my scratch pad now. I think. Well, I won't get rid of my scratch pad just yet. Let's run this on part 2 and see what happens. So we're gonna say var garden equals garden from input. And then we're gonna say is part 2. If that's the case, we are gonna do garden.calculate based on the sides. Otherwise, garden.calculate on the perimeter. And the total cost to fence the garden is that. Okay, let's go ahead and give this a go. Let's say .NET Run. Yeah, we're on day 12 still. So basically that, and then part 2. See if this is our guy. Yay! I am 24 hours late, but I have got it. Yeah, that was the first one. That was the first one of this year that took me multiple days, or basically, it took me about the same amount of time, or it didn't take me as long as the longest one I've worked on. I think the longest one I've worked on this year took me 6 hours. This took less time than that, but I had to split it up across multiple days just because of schedule and stuff. So I don't know. I guess you could call it cheating because I didn't really find sides. I found corners, but it gets you to the same place. Yeah, so let's see. I'm going to. What am I going to do? I'm going to pull this stuff out into separate classes like we typically do. Stick it in a namespace. Garden groups. That's fine. Yay. And then we got our garden class here. Yeah, cool. So let's. Oh, I need to do the README too. Code, README. And we'll update our table here. This was called garden groups. And I'm just going to say corners equal sides. Because that was the unlock. I'll be interested to see how other people did this. Now we'll commit this and say feature solved day 12 part 2. All right. Well, it took me an hour. It's 10 o'clock p.m. I'm a day behind. Day 14's puzzle is going to come out in an hour. Do I start day? I don't really want to start day 13. If I start day 13, I'm going to be up way too late. And I was up way too late last night. So I think what I'll do is I'll try to make the most of tomorrow. Knock out day 13 and day 14 before the end of the day tomorrow. And that will put me back on track for day 15. So, yeah, this was a short one. I just wanted to hop on and try to implement what I thought about during work today, and then hop off. So, appreciate those of you who stopped by and left some comments. I appreciate that. I'll be on probably tomorrow a couple times for a couple different sessions. I'll probably try to do 13 in one session, a couple hours or less, hopefully, and then maybe do that in the morning, and then come back in the evening and try to hit day 14. So that's it for me. I hope you guys had a good week. Hope you had a good Friday, good into it, and hopefully we start the weekend off on a good note. So I will talk to you guys. I'll talk to you guys later.